quite as expected. And because this is taking so long to cool and crystallize, while this cools, you can still be observing a little bit, but we're going to do something else so that we're not just sitting here literally watching crystals grow. So I'd like for you to turn to your igneous rocks concept map. It looks like this. I just want to go through this with you a little bit. Oops. There we go. Okay. So rocks, one of the three rock groups is igneous. So rocks can be igneous. They are formed from magma, which is referred to, that's a lot of times referred to as what forms underground, where it is crystallized because it cools more slowly, and these occur below the surface. These are intrusive. Inside, they are intrusive. Igneous can also be formed from lava, which crystallized above the surface or on the surface. Now when it says crystallize, that just means it cools, but those crystals are so tiny that they're unrecognizable. Igneous rocks are classified by their texture. They can be fine-grained, which those individual pieces of the grain size is the individual crystals. They can be rhyolite or basalt. Basalt forms at oceanic divergent boundaries. Rhyolite is the chemical composition of granite. It's just cooled quickly and fine-grained. Yes?
Which one did you say was divergent?
Basalt. Basalt forms like when the magma comes up at from the
Mid-ocean ridges.
yeah, mid-ocean ridges. You see that mostly. Okay, if they are mixed grained, so you see some larger grains and some tiny grains, it's intermediate, and we call this one porphyry. If the grains are larger, like what we saw today, this is from a plutonic rock. That just means it's intrusive. They can be granite or gabbro. And the difference is determined by the minerals that are in it. We're going to look at that in just a minute. Granite is most common. Now, if the texture is non-crystalline, if there's no crystals, it's glassy, this is a pyroclastic. Okay, what does pyro mean? Fire. What does clastic mean? Like chunks. Clasts are chunks.
Oh,
Okay? So it's like from volcanic eruptions. Not volcanic flow, but when it erupts and stuff comes out, you get the pyroclastic. This ends up as pumice. This is what you do your pedicures with, because there's little air bubbles. The gases were trapped inside the magma. Because whenever the magma cools, gases can escape. And if those gases don't escape, they're trapped in air bubbles. If the gases cannot even collect and they are still embedded into the magma, then you're gonna end up with obsidian or volcanic glass. The texture depends on the cooling environment. If they cool fast, you're gonna get fine crystals or no crystals. If it cools slowly, then please do not be thinking about your investigation that we're doing because we're not getting results that are supported by this concept map. If the cooling environment gives you slow cooling, maybe that's the difference between cooling on top of the surface or below the surface, then you're going to get large crystals.
Isn't that what happened with this one? The last one? Because it was hot, so it cooled slower. So we got large.
No, wait, it's hot, so it cools slower? And you got,
Large.
We think they're large.
well, do you have other crystals to compare it to?
In A, we did. It was
Okay.
cooled faster, and we got small.
Okay, we'll compare that in just a minute. So the rule of thumb is if there's larger crystals, it cooled more slowly. The heat was released more slowly. If it cooled quickly, then it's non-crystalline or microcrystalline. Now we're going to use this combined with the next, not the next page, but 2 pages over. Look at the very back of the handout.
Yeah, we got large. Fast.
Now our investigation, please look.
What does it say?
Our investigation on the properties of igneous rocks, please listen. We have 30 minutes to do this and finish up our lab, so let's finish, please. We're going to observe the properties of igneous rocks and how these properties are used to identify them, meaning the igneous rock. You're going to receive a basket like the one I have right here with 13 samples. There's a lot of samples. We're going to look at them. I'm going to grab number 1. This is this the right one? Okay, in my hand I have a white rock. I don't know what it is. I'm feeling it. It's very light. It's very scratchy. It's rough. So I'm going to go to, I'm going to record all my observations on my table. Then I'm going to turn to the back. I can't see any minerals in here. I can't see any crystals. I can't identify what it is. I'm going to look at the back of my table. Because there's no crystals, I can see, let's see. Looking at my table, this one, the texture tells me that it's pumice because this rock is froth-like. It's very frothy feeling. And when you get your samples, you will see this. The next rock I want to show you is granite, which I'm just telling you what it is because you've been looking at it all day. But we're going to keep granite. So if I look at this granite sample, I can see that there's quartz, feldspar, there's a plagioclase, but that's a plagioclase feldspar, but quartz and feldspars mainly. The accessory minerals or the minor minerals include biotite in here. You can see biotite. So I know that this is a felsic rock. Now I'm going to go down to the next section. The rock color, or the percent of dark minerals. In my sample, I have some dark minerals, but not very many. Let's say less than 10% dark minerals, which is going to keep it in this first column. So now I'm looking at granite or rhyolite. If it's coarse grained, it's granite. If it is fine grained, it is rhyolite. So I know that this one is granite because it is coarse grained. This is sample, no number, 8. Yes. Rowan is going to come around with your box of samples, and you can go through this with your samples. They have numbers on them. Now, be aware, some of these are minerals. They are not rocks, so there's minerals. So start with the ones that are obviously rocks. While you're waiting for your samples, I want to show you these two Petri dishes from a prior investigation with the Salal. Here's the one. Here are two Petri dishes. They were done at 2 different temperatures. The Salal was cooled at 2 different temperatures up here. I want you to point to the wall, point to the side that you think cooled most rapidly. Which one cooled most rapidly? Okay, if you're pointing at the board, I can't tell. Point to the right or to the left. Which one cooled most rapidly?
To the right. To the right.
Actually, smaller.
I can't hold on.
What did?
Not what you're observing here. Which one of these, guys, listen. The smaller the crystal, the faster the cooling occurred. So on this side, I can see crystals radiating out from central points here. So it's like this piece. If you observe what happened in some of your dishes, you know that once a crystal formed, then other crystals formed from it. So it looks like it's cooled here and radiated out here and maybe up here too. So I can see elongated crystals coming out from it. This one is crystalline, but these crystals are very tiny. I can't see distinct crystals in there. So I can infer that this one cooled more rapidly than this one. So this might model an extrusive rock, while this one model an intrusive rock. So if you have a cake and you pull 2 cakes out of the oven, you put one cake, wrap it in towels, wrap it in foil, and place it in a cooler and shut the cooler. You take the other cake, expose it to the breeze, and put it on your windowsill. Which one is going to cool faster? The cake you exposed to the air. The one that you did not expose to the air and you buried is going to remain warmer longer. So if those were rocks, the one that crystallized the fastest would be the one that you put exposed to the air on your windowsill, whereas the cake you put in the cooler wrapped up to insulate it would cool eventually, but it would take a long time to do that. That's what would happen with plutonic rocks, or rocks that formed under the surface. Yes, ma'am?
So, is it a misconception to believe that the faster cooling rocks are more dense?
Why would you say,
Because I picture them forming and I picture everything being closer together,
okay,
whereas this one is more spread out.
so let's look at this sample that we just found the first one we looked at, the pumice, that we said is so this one is volcanic, right? Would you like to feel it and tell me about the density?
I got it, I need one this weekend.
Okay, all right. Borrow this one. Or bring the other one.
Those are the
Yes.
crystalline structures that it's making this more dense.
Not necessarily.
Not necessarily. Right.
Okay, so does everybody have your box of rocks? Your tray of igneous rocks and minerals? Okay, so let's work on those and just keep track of your crystals as they grow. And there are there's 10 samples. Try to spend about a minute on each sample determining what it is. And remember that some of these are minerals and not rocks.